Okay, this is the video tutorial for lesson 7.4. We start off with a reminder about our tiles. This is supposed to actually say negative x squared here. So we have our squares, which are the squares, not surprisingly. We have our rectangles, which are the x's, and our smaller squares are the ones, and the ones that are shaded in are negatives. So while we're doing questions like this, what we're looking for, and we did this in Unit 6 actually as well, is if we're trying to find the dimensions, we can count the number of squares. So I got one square here, their length x, so I got 1x here. I got one rectangle here, so I got 1. So x plus 1 is this one, dimension here. As you work across the top, you do the same thing. So I got 1 square, so 1x. I got 4 rectangles, so 4. Now I'm not going to put 1x, I'm just going to put x, and then I'm going to put plus 4 because there was 4 rectangles. If they'd been shaded in, I would have actually put negative 4 here. Now to find the total area, I can just look at the picture and see what I got here. So I got one big square here, so that would be x squared. I have 1, 2, 3, 4, 5 rectangles here, so that's 5x. And then I have 4 little squares at the bottom, which would give me 4. And for each of these, I can just click just to check that they're correct. Now, you might want to pause the video and try these next 2 slides yourself. After you've done that, if you want to follow along. So down the side here, we've got x and 2, so x plus 2. Across the top here, I've got an x and 1, 2, 3, 4, 5, 6 rectangles this time, so that would be x plus 6. And then as I come down to write my area, I have one big square, so that's x squared. Count the rectangles up, that should be 8, so 8x. And count the little squares up, which should be, well, if you were doing this by hand, you could multiply x plus 2 times x plus 6 and use a grid to do that as well. Let me check. I didn't click submit. Let me just check. That's fine. And so is that one. Now this time they haven't given you anything, so using the same idea, down the side is x, and then 1, 2, 3. So that is x plus 3 is one factor. And then across the top here, there's just 2 rectangles and 1 square, so 1x plus 2, or just x plus 2. And I should be able to submit that as well. And then I had to scroll down a little bit here, but you can see that there's 1 square here, so this would be x squared. If you add up all the rectangles, you can see that there's 5, so plus 5x. And I got 6 squares at the bottom here, so that would be plus 6. And let me just scroll down. Yeah, there we go. That one is good. Now, this talks about what happens, though, if we don't know the tiles and how we're going to come up with the answers. Well, we're going to do basically what we did before in a previous lesson. What we're going to do is we're going to use the properties of graphs to help us find what that actually looks like. So I went ahead and graphed this equation already. So this is really the question. Factor completely this expression, and we've got some answer choices. And we're just going to go back and we're going to use Desmos to work out what's going on here. So first of all, we just look at what the x-intercepts are. So -4 and -3. So I'm just making a note of those. And then I'm doing the opposites of each of those. That's the important rule. The connection between those intercepts and the factors is that it's the opposite sign. So if it says -4, I'm going to put +4. Notice how it goes through here straight away. So that's a good sign to begin with. Where it says -3, I'm going to put +3. Now I'm going to switch that off just for a second because I want you to see what happened. Here was the original equation. And when I switch this on to see what it looks like, notice that it's exactly the same as this original question. So I know that I have the right answer for this. So x plus 3, x plus 4, they have it the other way around, but that's perfectly okay. And you could share your reasoning as well, mentioning the fact that we're looking at opposites. Same thing for this question. Factor completely b squared minus 6b plus 9. Well, I'm going to type it in, but I'm not going to type b. I'm going to type in x, or else it won't draw it. Just one intercept this time, right here at 3. So if I'm doing a factor, remember I'm doing the opposite. Now, notice, though, for this one, this is not the same. So although I did the opposite this time, I got a different picture. And this is one of those special ones we talked about last lesson. It's called a repeated root. Although we only have one answer, for squareds, if we have that one answer, we're just going to write it out 2 times. So x minus 3 and x minus 3. And once again, notice that this is exactly the same. You could also write this answer as well, as it is x minus 3 times x minus 3. as x minus 3 squared, and I'm just going to show you as well. You can also see that that is the same thing. So let's have a look what we picked for this question. It was, there we go, B. I think they were both minus. Let me just go back and quickly check. Yes, x minus 3, x minus 3. So switch it back to B, so B minus 3 and B minus 3. Now, this question links in more with what we did in lesson 7.3. The reason being is, what happens if we have these decimals here? So negative 0.5 is not too bad. You might recognize that as negative 1/2. You can just click the fraction button. But this one here is going to be problematic. This 0.667, because actually you can find a fraction and it'll give you a fraction, but unfortunately it's the wrong fraction. What happened here is actually it was 0.66 repeating, and then the last 6 rounded up to a 7. So as I add 6's in, it does work out a fraction, then it disappears, and as I keep typing them, and actually no matter how many I type at this point, it will leave it at 2/3. So 0.667, one is an important one to try and remember as 2/3. Now, as we're doing the factors for this question, we're doing the opposites here. So where it says negative 1/2, we put positive 1/2, but we bring this x up to the front here. So it actually becomes 2x plus 1. And I'm just going to get rid of some of that other stuff. It does go through this intercept, so this is probably a good sign so far. For the 2/3, do the opposite, which is minus 2/3. But same thing, take that 3 and actually bring it to the front and put it in front of the x. So really, it should just be 3x minus 2. Notice that it's the same exact answer when I switch it on and off, so we know that we have the correct answer for this question as well. This time it only asked for one factor. Whoops, I didn't actually select the answer here, so let's go look back, see what the answers were. 2x plus 1, 3x minus 2. So there's 3x minus 2, so we can select answer choice D. Same idea. The question is actually on here. 3x squared plus 19x minus 40. They have told us, or I gave you this in the question, besides x plus 8, what is the other factor? So we'll see why x plus 8 is a factor in a minute. There's negative 8. So when I do the opposite, that would obviously become x plus 8. Oops. And for the other one, this will probably be a decimal. 1.667. So kind of like the last one. It's really 1.66, and the 6's just continue. Let's hit the fraction, see what it says. 5/3. So I'm going to actually just fill it in straight up here. So instead of 5/3, to do the factor, we do the opposite, which is negative 5/3. But then we move this 3 up into the front here. So really, it just becomes 3x minus 5. Whoops, that wasn't delete, was it? There we go. And I might have to zoom out a little bit, but hopefully you can see that that's kind of the same picture here. Let me switch it off, and then on again. There you go. And you can see that that's exactly the same. So 3x minus 5 is my other factor. As I'm moving on to 16, remember, if you want to check your answer, you can also type in a factor and make sure it passes through the root. It does say it might still be the wrong answer, but if it doesn't, then you can definitely eliminate that answer. Now, we're going to start looking at special cases. All the questions I've given you so far just had a GCF of 1. So if you look at 1x squared, 7x, and 12, all these questions that we just looked at had a GCF of 1. But what happens if there isn't a GCF, or there's a bigger GCF than 1? Well, let's take a look at that in our next question then. Oops, I didn't mean to quite zoom in quite as much as that. I have to toggle around with this a little bit. Something got a little strange here. I'm not quite sure what happened. I can't actually zoom out for a second. All right. Here we go. So here was question 18. Completely factor, and then there's a list of options, and we have to check every single one that's correct. So let me just go back to the question. Let me click on those intercepts. Negative 2.5. And 5. So 5, obviously no problem. We can deal with that one easily enough. This one, we'll change it into a fraction. So for the 5, do the opposite and put x minus 5. Oops. think that just made it worse, didn't it? There we go, that's a little bit better. Probably still zoomed in a little too much, but hey. The negative 5 over 2, do the opposite. So put x plus 5 over 2. But that bottom number, we're just going to bring to the front here, and it gives us 2x plus 5. Now, you'll notice this is not exactly the same picture. So I know this is not exactly the correct answer. But notice it does go through the intercepts, which is kind of what we're trying to do. And the reason it doesn't go through is there's a GCF this time. If you look at those numbers at the top and actually check the GCF of 10, negative 25, and negative 125, you'll see that the answer is 5. And if we put a 5 at the start of our answer, look what happens. It changes it to exactly the correct answer. So, GCF is important to check for numbers, even though we haven't done that for a while. And reminder, we didn't do it on the other questions because it just happened to be 1. But you should always check just to make sure. So, let's see what we actually have as an answer here. We have to select all of these. So, certainly 5 was one of those. X minus 5 and 2x plus 5. X minus 5, 2x plus 5, and 5. And on a test, if we miss one of those, then we would get the wrong answer. 4x squared minus 400. There is also a reminder about what is the greatest common factor. So let's go back to the graph. I already typed it in. I got negative 10, and I got positive 10. So this one I can do pretty quickly. Instead of negative 10, I can do positive 10. Instead of positive 10, I can do negative 10. Once again, notice this is not exactly the correct answer, even though I've done the intercepts. And the reason being for that is there is a GCF for this question as well. So if I do the GCF of 4 and negative 400, it will come out as 4. You might have recognized these are both in the 4 times table. Look what happens as I make 4 a factor. We actually get that exact same graph. So it's something that's important when we're doing questions. Just make sure that you don't miss that. It is important to finding out what your answer is. So I got to pick 4, I got to pick x minus 10, and I got to pick x plus 10 as well. So just a reminder, don't forget to look for the GCF as well. And 2 questions to finish with on slide 23. If you have a question that has 2 letters and it asks you to factor, ignore the second letter, and we can figure out the answer from there. As the first letter is A, you would type this in as x. So I would do 25x squared minus 64, and that's it. I wouldn't put the second letter in at all. So just 25x squared minus 64. Now you can see I've got the graph drawn here already to speed things up a little bit. I have my 2 intercepts, which I've already typed in, and I have my factors, I have my fractions already there. So for the top one, instead of negative 8/5, I'm going to put positive 8/5. But that 5, once again, I want to bring it to the front of the question. Do the same for this one. Instead of positive 8/5, do negative 8/5. But bring that 5 to the front of the question. And hopefully what we should notice is it's exactly the same picture, so we know we have the right answer. If you want to check the GCF, like we did on that last question, 27 and negative 64, you'll see that it's, you'll see that it's 1. So 1 obviously doesn't change anything. Times anything by 1 doesn't really do anything. So 5x plus 8, 5x minus 8. So notice there's 1 of each sign, which is like this answer here. Notice it can't be this one because they're both negatives. And we certainly didn't have 25 as an answer, so I know that's wrong as well. And this is both pluses. So actually, just knowing that one was positive and one was negative was actually enough for this question as well. Last one, 4n squared minus 18n minus 36. So instead of n, I'm going to type in x. I'm going to look at my intercepts, negative 1.5 and 6. So negative 1.5, change it into that decimal, change it into that fraction. So negative 3 over 2. And to do the fraction, do the opposite. So make it positive 3 over 2. And bring that 2 up to the front of the question while we're doing this. And the 6 that we have here, do the opposite. That would be minus 6. Notice it doesn't quite line up. It's not exactly the same here. So perhaps there's a GCF for this one. So let's just quickly check. GCF of 4, negative 18, and negative 36. Notice I'm only using the numbers at this point, which is 2. So it looks like 2 is a factor. And if you type 2 in, notice now that this graph is exactly the same as that graph. So 2, 2x plus 3, x minus 6, they're all factors. It only asks you which one works, so 2x plus 3, or in this case 2n plus 3, and then we should be able to check as well. And that should conclude it for this one. There is the practice exercise, assignment 7.4, and there's also a video tutorial that goes with that as well.